Hello everyone, welcome to this session for complete revision of engineering mechanics. In this session we'll see how to find the resultant force of a system of forces in different methods. Here we have two different methods. The first one is analytical method and the second one is graphical method. In analytical method we have three methods. The first one is parallelogram method. In this we have two forces which are acting concurrent and coplanar. And in Lamine's theorem we have three forces which are acting concurrent and the coplanar. And coming to the method of resolutions, we have a number of forces or system of forces acting coplanarly, but it is non-concurrent. Forces which are acting will be non-concurrent forces. That means you can solve the problems which are related to coplanar non-concurrent forces. And in graphical method we have two methods. The first one is polygon law and the second one is triangle law. And now we'll start with parallelogram law. Here first, before seeing the definition of parallelogram law, first we'll try to understand that, see, two forces, we already said that two forces will act at a point. That means these two forces should be coplanar and the concurrent. Mainly the first thing you have to remember is the parallelogram law. If you want to apply the parallelogram law, the forces should be a concurrent. And now we'll see the definition of your parallelogram law. If two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram. See, this point is important as per the parallelogram law of forces. Their resultant may be represented in magnitude and direction by the diagonal of the parallelogram, which passes through their point of intersection. Which point of intersection it is? So when two forces are acting on a particle or a body, and that is your point of intersection. And now consider these two forces are adjacent to each other, and these are the sides of your parallelogram. Just assume that these are the sides of your parallelogram. And now your resultant is diagonal of your parallelogram. Okay, diagonal of your parallelogram. This is your resultant as per the parallelogram law of force. And this is your F1, which is force 1, and this is force 2. Okay, so once again, according to the parallelogram law, when two forces acting coplanar concurrently, or if the forces are coplanar and the concurrent, then the resultant will be the diagonal of that parallelogram, which is formed by the two forces, that is the adjacent sides of your parallelogram. Clear? And now the angle between these two forces will be theta, and the angle made by the resultant with the horizontal force or with the any other force. But if you consider, we are considering the F1 as your horizontal force, so it is very convenient to take the angle with respect to the horizontal force, and this angle will be alpha. Okay, and now we'll see the formulas for this parallelogram law. See, according to the parallelogram law of forces, your resultant is equals to square root of force 1 square plus force 2 square plus 2 into F1 F2 cos theta. What is this theta? And this theta is the angle between two forces. And now you can see here, and this is one force and this is another force which is like F1, and this is of F2, and these are making an angle of theta. And now your resultant is making some angle with respect to the horizontal, that is F1, and that angle is alpha. What about this force? How you are going to find about this force? And that for that formula is tan alpha is equals to F2 sin theta divided by F1 plus F2 cos theta. So now what is F1 F2? Forces whose resultant is 2 required to find out. And what is theta? Angle between the forces F1 and F2. alpha is angle which the resultant force makes with the one of the force, say F1, one of the force. You can take this one or this one, but for the convenience you are taking this one, which is alpha. But moreover, you have to remember one point here. The most important one is, say this, you will get confused with this formula in any competitive exam. Like they will ask you by showing a figure like this, and this is the resultant, and that is making some angle with respect to the F2 force, okay, and this is your F1 force. And now this equation is wrong for alpha. To find the alpha, if you write the formula like this, and that is your wrong one. Why? Because here alpha is making angle with respect to F2, not with respect to the F1. Okay, when the alpha is with respect to the F1, then this formula is valuable. But now this alpha is not making angle with respect to F1, it is making with respect to F2. Then your formula will be F1 sine theta divided by F2 plus F1 cos theta. It holds good for angle if it is given with respect to the F2. And this is your previous TSPSC question. And now if the angle which the resultant force make with the one other force, you can see here, which is F2, and this is your equation which we discussed just now. And moreover, based on this resultant equation and based on this tan alpha equation, see, if the forces are acting in any particular angle, and what is the angle of this? 180 degrees, but these are concurrent forces, moreover coplanar too. So now if the angle which is theta equals to 180 degrees, we have one condition, that means we will get the resultant in other formula. And if this theta varies, what is your resultant? We'll see here. The first one is, if theta equals to 0 degrees, substitute theta equals to 0 in the resultant formula which we already taken from the parallelogram law. Okay, if theta equals to 0, if you substitute here, what the resultant you are going to get is R equals to F1 plus F2. And if theta equals to 90 degrees, the resultant is equals to the angle, and that equals to F1 square plus F2 square. If theta equals to 180 degrees, that means the forces are acting in the same straight line but in opposite directions. But coming to the 0 degrees, the forces will act in the same straight line but in same direction. Okay, act along the same line, but here it is acting in the opposite directions. And for that your resultant is R equals to F1 minus F2. And coming to the fourth one, if two forces are equal, that is when F1 is equals to F2, say just as F, then what is your resultant? And if you substitute that F1 equals to F, F2 equals to F, then you are going to get this equation. And now 1 plus cos theta, from the trigonometric equations you will get this equation. And if you simplify that, what you are going to get is 2f cos theta divided by 2. And this formula is very important for all the competitive exams. Okay, here he asked in terms of F, right, the force given as F, but in the previous competitive exams they given the force with respect to P, and the options will be like 2p cos theta by 2. Okay, don't confuse with this. And this one is very important. When two forces are equal, then what is your resultant? And next, coming to your Lami's theorem, and this will be useful to solve the problems when the system of forces are acting concurrent and coplanar. Here we are going to take three forces. Coming to the parallelogram, we are going to take two forces which are coplanar and the concurrent. Here in the Lamis, these are concurrent and the coplanar, or coplanar and the concurrent. But here we are going to take three forces, and we'll start with your statement of Lami's theorem. If three coplanar forces acting at a point be in equilibrium, okay, these will be in equilibrium, then each force is proportional to the sine of the angle between the other two forces. It is the angle what you have to take is between the other two forces. So now see this figure. Here we have a point or a particle on which three forces are acting like P, Q and R, and these three forces, by acting on a body, the body is in equilibrium, okay, and between two forces there is some angle, right, which is like alpha, beta and gamma. And if a body is acted upon by this system of forces like three equilibrium forces, then you can solve that problem by your Lami's theorem, which is P divided by sine alpha, and this is your force and this is the angle between other two forces, you can see here, and this is your P, and the alpha is the angle between other two forces. This angle is not acting with respect to the P, right? This angle is opposite to your P. And now Q divided by sine beta, again this beta is opposite to Q, and R divided by sine gamma, and here also R is here, your alpha is in opposite direction of your R, and that too it is the angle between the two forces. And moreover, and this is very important equation which you already seen in your primary and secondary educations, like this is your sine rule. We can also call Lami's theorem as sine rule, which is there in your trigonometry or some other in primary educations. And once again, the Lami's theorem you are going to use for the forces which are acting coplanar and the concurrent, and here the forces should be three which are in equilibrium. And moreover, for example, just think that this is your one force and this is your another force which are acting simultaneously, and you can find your resultant of these two forces by parallelogram. For example, if you're going to get a resultant like this by the parallelogram law, it is R, right? So now you can directly take this R. See, here R is not a resultant, it is just a force, but here R is a resultant. Okay, just make it as R dash. R dash is your resultant, R is a force. Leave this R and take these two forces which are P and Q and find the resultant by parallelogram law. And after finding the resultant, you can directly take this force as R. See, if your resultant is R dash, your force which is opposite to the two forces is R, right? You can directly take this. This force we call as equilibriant. Okay, this force is the equilibriant. Why? Because the equilibriant force is equal in magnitude with the resultant but opposite direction with the resultant. Okay, equilibriant is equal in magnitude and opposite in direction with resultant. And in this way you can find your resultant, or you can find the other force which is the equilibrium of the system of forces. Clear? And coming to the third one, which is method of resolutions, and this is the most important method to solve your system of forces or to find the resultant of system of forces. And this method is used to find the system of forces when they are coplanar and the non-concurrent. Coplanar and non-concurrent. Okay, So simply first we'll see the forces which are acting on your body, which are coplanar and the non-concurrent. Just think that this is your beam which is of reaction R1 and this is of reaction R2, and now if a number of forces are acting on this, like F1, F2 and here F3, and take another force which is acting in some inclined position of theta, like F4. See, these are planar in xy direction or xy plane. These are the forces which are acting on a xy plane or xz plane, any two planes. Okay, those are coplanar one, and moreover these are not a concurrent, so that's why you're calling it as non-concurrent forces. So for this type of forces or system of forces, you can find the resultant by method of resolutions. Here, by method of resolutions, here we have few points how to solve your problem by method of resolutions. The first one is resolve all the forces horizontally and find the algebraic sum of all the horizontal components. That means you have to resolve all the forces horizontally. For example, if your force is acting in a inclined way, which is like making theta with the horizontal, and you can resolve that into two components, right, which is like a horizontal and the vertical component, and like that there will be a number of inclined forces which are acting on your body, and resolve all the forces and take the only horizontal forces and sum all that horizontal forces, and that's your resolve of all the forces horizontally and find the algebraic sum of all the horizontal forces. And next one, in the same way, after having some components of a inclined forces, we will have the vertical, right? So resolve all those forces vertically and make the sum of all those vertical forces. Okay, summation of all the vertical forces. The first one is summation of all the horizontal forces, and the second one is summation of all the vertical forces. And now we can find the resultant of those components, which are summation of all the horizontal components and the vertical components, by taking square root of sum of all the horizontal forces square plus sum of all vertical forces square. And this is how you're going to find the resultant of the coplanar non-concurrent system of forces. And coming to the theta, that means we required in which direction it is acting, right? If you want to know the direction of the resultant, then you have to take tan theta is equals to summation of all your vertical forces divided by summation of all your horizontal forces, and this is your magnitude of the resultant, and this is used to find your direction of the resultant. We will continue in the next session. Thank you.